Now, in last class, we have seen how to do the hardware conversion and how to make a logic here, okay, and how to download on using simulation. So here you can see we are having some gates, S, not, or, XOR, okay, NAND, NOR, X not like that, okay. So we have to make this gates today, okay. We try one by one, AND gate, OR gate. For AND gate, you can see we're having two inputs and one output. 0 0 0 1 0 0 0 1 0 1 1 1, right? So we have to make this operate this condition using that toggle switches. Okay, the toggle means that in simulation option we are having this input variables, right? Now similarly we have to operate for our condition. So let's see how to make this circuits here. Now first we see the AND means both, okay, or you can say series. We have to connect two inputs in series. So I connect this input plus one more input here. Now we are writing I0.1. Okay, save and load. Now how to check the result here? I0.0 and I0.1. So here you can see this is I0.0 and this is I0.1. And where's the output status here? It is off, right? Now the input status is 0 0 here. Okay, for the AND condition, first 0 0, A and B are 0 0. That means the inputs are off. Okay, so 0 0 0. If I operate 0 1, tick mark means 1, right? So I'm operating this one. This is 1 0 1. Here also you can see 0. This is green means it is 1. So 0 1 0. Now I operate the 1 0. So 1 0. This is 1. This is 0. Output is off. Now last one 1 1, right? If when both inputs are 1, then your output is 1. So this is the condition for your AND condition. Similarly, make a condition for OR. Take one more network. Then I add one input here. You connect this in parallel. Select before this input here. Then we have this open branch. Add one more input. Close. Then I connect one output here. So I 0.2, I 0.3, 0.1. Save. Download. That's one time. Comfortable with you. No, I0.2 and I0.3. So for OR condition, what is the table? 0 0 0 1 0 1, right? And 0 1 1 1 1 1. So only for 0 0 it is 0. For remaining any switch is on, your output is on, right? That is a OR condition. So 0 0 0, right? 0 0 0. Then 0 1. This is a 0 1 1, right? 1 0 1. If I operate both 1 1 1. Okay, so like this we have to operate here, okay, and check the result in the logic whether the outputs are coming properly or not. Okay, then what's the next condition? And we are having NAND gate. For NAND gate it is a reverse. You can see 0 0 1, right? 1 0 1 0 1 1 1 1 0. It is reverse. Okay, zeros are ones, ones to 0. So how to make a NAND gate here? So here it is not necessary that we should use only NOS for your logic. You can use NCs also, okay, to satisfy our condition, because when your inputs are 0, okay, for NAND gate, your output should be on. So I take 0.4 output here, I take NC here. NC, if I take without operating input, your output will be on, right? Now, so shall I connect this in series or in parallel? If you connect this in series, if this is breaking, this will be off, but this should remain on, okay? So you have to use this in series. One more NC in series. So one more input without operating, the second input also should be on, okay? So I'm taking NC in parallel for NAND gate. You can see there. Now 4 and 5, okay? These are 0 0 here, okay? The switches status are 0 0 and your output is 1, okay? Now if I make 0 1, 0 1, right? This is 0, but this is 1, reverse, okay? So the output is 1, 1 0 1. If I operate both, 1 1 here, 1 1 0, there is a NAND gate, okay? These are we have to operate and make the logics here. So here I can write here and okay. Similarly, we have to make NOR gate. Okay, in NOR, we have to take two NCs in series and one out. Okay, okay, R0.7 plus R6. You can see the NOR gate here. NOR gate, if any two inputs are on, sorry, off, it is 1. If any inputs are 1, it is 0. Okay, so without operating these inputs, right, this is 1. If I operate any input here, right, 0 1 0 1 0. If I make 1 0 1 0 0. If I make both 1 0. Okay, so this is your OR gate. Okay, this is NAND gate and this is sorry NOR gate. So OR gate. Similarly, we are having two more gates, that is XOR and XNOR. Okay, in XOR you can see 0 0 0 1 0 1 0 1 1 and both are 1, output is 0. Here you see OR gate and XOR gate. OR gate and XOR gate both are similar. First three conditions are similar, but the last one, if both are 1, it should be 0. Okay, so that is one change, right? So I have to connect two inputs in parallel, just like in OR condition. Say I 1.0, next byte number I will go I 1.1. Okay, two inputs in parallel and one output here, Q 0.4. Okay, now so here this will work like a OR gate, but when both the inputs are on, this should be off. So we have to interlock here. Interlock means select here, take one NC, and select here, take one more NC here. Means if you are operating this input, it should get here. So Control C and Control V. If this is operated, it should get there. Control C. It is called interlocking. This address I am using, and see here for breaking. This address I am using here for breaking. Okay, it is called interlocking. Means if one is on, another should be off. So here you can see the result, right? I add one more input variable here and change the byte number to 1. Now 0, 0, 0. If I operate any one, 0, 1, the output is 1. So if this 0, this is 1. So from here you can see it is 1. 1, 0, sorry, 1, 0, 0, 1 only. So 1, 0, 1. If I operate both 1, 1, you can see here. If I make both on, this is on here, but this is breaking here. And it is on here and it is breaking here. So it is interlocking, means it is disconnecting the logical status. Okay, so your output is going off here. Okay, so this is your XOR gate. Similarly for XNOR, means reverse of that. In this case, we use two NORs, two LCs in parallel. So I 1.2, same way I 1.2. Yes, focus on the. Here you can see here XNOR gate, right? 0, 0, 1. If any one input is on, it will be 0. If both inputs are on, again it is 1. So right now your inputs are 0, 0 here, 0, 0. The output is 1. If I operate any one, 0, 1, it is 0. Okay. If I operate 1, 0, again it is 0. If I operate both, it is 1. Here it is breaking and here it is making. The same address we are using here. Okay. So only two inputs are there, right? That's why we have to take these two inputs here. Okay. We are not adding any more addresses in this XOR and XNOR gates. Okay. Only two input addresses I'm using. Okay. I0, I1.0, I1.0 here. I1.1 here, again I1.1 here. Okay. So this is your uh, your now there's one more condition. For example, one more logic. If I'm having three switches, means three inputs and three outputs. Okay. So for these three outputs, I have a condition like first lamp. Okay, first output. So three outputs are three lamps. The first lamp should be on if any one of the three switches are on. Okay, if any one of the three switches is on, okay, then only first lamp should be on. For second lamp, if any two switches are on, means the same three switches out of the same three switches, if any two switches are on, it can be like switch 1 and switch 2, or switch 2 and switch 3, or switch 3 and switch 1, right? So here we have to write those two switches in series and then parallel with another two switches. Okay. And for a third lamp, if all the three switches are on, if all the three switches are on, only lamp 3 should be on, and first and second should be off. So first and second will also go on because the same inputs, right? It is also having the same inputs. That's why we have to interlock here. Okay, so I'll connect with I 1.4, some output like Q1.0. Okay, say lamp 1. What is lamp? I'm adding two more inputs here for OR condition. Okay, so I 1.5 and I 1.6. Okay, this is a OR condition. Now, so if any one switch is on, then the second lamp, if any two switches are on, right? So I 1.4, same input addresses, and I 1.5. So Q 1.1 should be on. And again, I 1.5 and I 1.6, second and third switch, or I 1.6 and I 1.4. Okay, third and first switch. Okay, but for the third one, if all the three switches are on, then lamp should be on. So I 1.4 and I 1.5 and I 1.6 and that is Q 1.6. If download, now here you can see when I operate these inputs. Okay, and I take the output file also. Now, type number 1. Now, so here are the three switches 4, 5, and 6. Okay, if I operate the first switch, right, first lamp is on. Okay, if I operate the second switch, first lamp is on. If I operate the third switch, first lamp is on. Now, second condition. If I operate the two switches, first and second lamp is on, but first is also coming on. This should go off. Okay, only one lamp should be on at a time. So we need to interlock. So how to interlock? Here what is happening? This output is going on, right? So this status I can use here. This output status we can use here to interlock. So Q1.1. Okay, so let's see download monitor. Now here you can see when this is on, it is breaking here. The first lamp is off. Okay. Now I can operate second and third, right? For second, third also. Second, third switch. This is on and this is off here. And if I operate first and third, right? Second is on, first is off. But if I operate all the three switches, this is on, but this is still on. Okay, this should go off, and this should also be off. So we have to take one LC here with the third lamp and one LC here with the third lamp. So Q1.2 Q1.2 save, download. So when this is on, this is breaking here and here. So both the outputs are off. Only third lamp is on. Okay, so this way we have to make a logic here. Okay, by using interlocking method. Okay, this is one method. Okay, for this condition. There is one more method. Okay, you can do using only NOS and NCs. Okay, like so here I 1.4 5 and similarly here same addresses I 1.4 5 1.5 5 1.6 same addresses we have to give here I 1.4 I 1.5 and here I take another addresses Q 1.3 onwards Control C Control V. Then I just delete this and take one more hello and I give I 1.5. Okay, so here I delete this, take one more hello I 1.6. Here also I delete this and seal and select one hello I 1.4. Okay, then here Q1 prompt here same way only three hellos by I 1.4 I 1.5 I 1.6 then Q1.5. Let's see here. So same inputs. Okay. If anyone input is on, you can see Q1.3 is on. Okay. If you have two inputs, 1 and 2, but this inputs only Q1.4 is on, these are breaking here. Okay. So these are breaking here, here, and here. So that's why it is not coming through these. Okay. Similarly, if I make all the three switches on, here it is breaking, here it is breaking, here it is breaking. Here also it is breaking on. Okay. So that's why only for unknown it is on. So all lenses are breaking. So these two outputs are off and this is on. Okay. Like this we are having two methods for making this logic. Okay, possible. Only by using the MOS IO addresses and here the first example we have seen with the output address interlocking. Okay, this is another method. And there are different methods you can use